Hopefully my internet, I'm not sure if recording like affects internet quality, but hopefully everything's just like usual. So as I mentioned before, when I saw you guys on Tuesday, the plan for today is to cover just a bunch of practice problems that you guys may see. I think that going over extra problem sets and problem sets is probably going to be the main objective. And then when it comes to Tuesday, when I see you right before the midterm, we're going to just cover even more practice problems. So that's the objective for today. And so with that being said, unless there's any questions, I'm just going to go ahead and get started and just kind of run through as many of these problem sets as possible. All right. So the first one that I want to start off with is from extra problem set 4. And this is going to be question 13. Right. And as always, I'm going to write down as much of the information as I can, but you guys are also welcome to just kind of follow along as well. So we have that the utility function with respect to leisure and consumption is equal to 12 times r to the 1/2 times c to the 1/4. And we're given that the budget constraint is WR plus C equals M plus W L bar. Notice that there's no P, which implies that P is equal to 1 in the question. And so we're told that L bar is equal to 12, M is equal to 0, and W is equal to 20, right? And so I'm going to have you guys kind of help me along the way, right? So the first question is going to be, how many hours, right, will Fred choose to work? Right, so L star. And so does anybody want to maybe get me started with this, right? Like based off of the problems that you guys have probably done before, how am I going to get to this end goal? Like what's a good first step?
Find the marginal rate of substitution.
Yeah, okay, I agree with that. So we have that our MRS is going to be equal to 1/2 C over 1/4 R, which is just going to be equal to 2C over R, right? And we know that the price ratio on our labor supply model is just going to be the wage rate over the price, which is just going to be the wage rate over 1, right? So I'm just going to set it equal to W, right? And I might as well just set it equal to what it really is, right? So this we know is equal to 20, right? And so we get 2C is equal to 20R, which implies that C is equal to 10R. And so now when we plug this back into our budget constraint, right, we get that WR, right, is 20R plus C is another 10R, right, is equal to 0 plus W times L bar. So 20 times 12 is 240, I believe, right? So all of that is equal to 240, which means that 30R equals 240. And so R is going to be equal to 8. And am I done? Have I found out what I wanted to find out?
No.
Right, exactly. So I want to emphasize that a lot of times they're going to ask you for the number of hours that they worked, right? But we know that the first time around, the only thing that we can really find is going to be the amount of relaxation that they are going to consume. And so we need to use the fact that L bar equals L plus R in order to solve for L. Luckily, we know what L bar is and we know what R is, which means that this is going to be equal to 4, okay? So pretty straightforward, right? You'll notice that there's a lot of similarities between this kind of problem and a lot of the optimization problems that we've worked on before. And so with that being said, right, there's a second part, and this is going to be income, right? So how much is this person going to earn? Well, we know that how much they earn is going to be what they have, right, without working, plus what they have with working, which we know is equal to M plus WL. Notice that it's not L bar. And so this is really just equal to 20 times 4, which is going to be equal to 80. All right. And then the last part is L bar if M is equal to 1,000, right? Well, so now we need to kind of reevaluate things if we have a non-wage income, right? Because we know that non-wage income has a role in the number of hours that we're going to choose to work. Typically, an increase in M, right? If you remember some of the substitution and income effect stuff that we talked about, right? An increase in M is going to result in more leisure and more consumption, just generally speaking. So we can maybe assume that L is going to decrease, right? But we need to find a numeric amount. And so I'm going to use some of the work that we used in part A, mostly the fact that instead of having a 0 here, we'll have a 1,000, right? And so this becomes 1,240, right? And so instead of 30R being equal to 8, or 30R being equal to 240, we're going to have that 30R is equal to 1240. And I believe that should be 80, right? But I want to make sure. Oh no, that's whoops. That's why you make sure. It's equal to about, right? R is going to equal to R is going to equal to roughly 41, right? 0.333, right? But you notice that this surpasses the number of hours that this person has available to them, which means that in this case, they're only going to have 12 hours to relax, which means that this is what R is really going to be, right? Because they're constrained by the number of hours in a week. And so obviously, if R is equal to 12, that's going to tell you that L is going to be equal to 0. All right. So hopefully you guys feel pretty good about labor supply. I think that generally speaking, these problems are a little bit easier to figure out just because of how similar they are to some of the stuff that we did earlier in the quarter. Okay, so if there's no questions, I want to move on to another question from that same exact problem set. All right, so let me just erase the board. And let's see if there's another one. I kind of scoped out some of the questions to make sure that they were good. Oh, this is a good question. This is from the same problem set. Right, and it's going to be question 11. Right, and we're told that their utility function, right, this is going to be a labor supply question, is going to be R squared times C. And we're asked for the labor supply function, right? And so this, right, has parameters W and M, right? So we want to basically see how L is going to change with different inputs of W and M, right? And this should hopefully remind you of demand functions that we did earlier, right, in the quarter. So with that being said, right, we're told that W is going to be equal to 10, and M is going to be equal to 320, right? And L bar is going to be equal to 168, right? So there's two different parts. There's the labor supply function, and then there's actual labor demanded, right? Or labor supplied in general, right? So the difference between a demand function and quantity demanded, for example. Okay, so for finding my labor supply function, does anybody want to maybe get me started with an idea that they have? I think maybe knowing or remembering how we set up demand functions previously, right, should be a helpful hint here. Okay, well, if we're stuck, right, what's something that we can always do if we're kind of stuck in place, right? What's something that I've always recommended we do if we don't really know how to move forward with a problem?
You can find the MRS.
Okay, yeah, so MRS, right, and we know that this is going to be equal to 2C over R. And what am I going to do with the MRS, guys? All right. Yeah, okay. Yeah. So equal to wage. And do I want to have the value of wage, or do I want to leave wage general? Okay. Right. And so the reason that we want to leave it in the most general form is because we want to see what the labor supply is for all levels of wage, right? We don't want to see what it is at just one specific value, which is 10, right? We want to see it for any value, right? Such as like 10.3534, right? Or any other number, okay? So now that we have our MRS set equal to the wage, what can I do with this? All right. Does anybody have any ideas about maybe what we can do with the fact that 2C over R is equal to W? Right? Here's our here is our budget constraint, right? So now how can we utilize this fact?
You can make C equal to WR over 2.
Okay, yeah. So you want to find C in terms of R so that R becomes the variable of interest. I like that. Right? So C is going to be equal to WR over 2, right? Which means that WR over 2, and I'm going to kind of do some algebraic steps here. I think that you guys should follow, but if you don't, right, that's okay. I'm pretty much just multiplying this WR by 2 over 2 so that I can get the same denominator, right? And I get 3WR over 2 is equal to M plus W L bar. Okay, now any suggestions from here?
Could you replace R with isn't R equal to or L bar equal to L plus R? So can we replace R with that equation?
So are you suggesting substituting R with our what am I trying to say? With L bar minus L?
Mm-hmm.
Okay, yeah, so let's give that a try. So we get 3W. And actually, while I do that, I'm just going to do 2 steps in one. I'm going to isolate R and then leave it as L bar minus L, right? So I'm going to have that L bar minus L is going to be equal to 2 times M plus W L bar all over 3W. Okay, so I'm going to erase some of the stuff on the top just so that I have enough room to finish the problem. And I have L here. And I have M and I have W, right? So I have all of the parameters that I'm looking for, right? Now, in order to kind of just send this home, right, we know that we want to find L by itself. And so this is just left to simple algebra, right, where we get that L is going to be equal to L bar minus whatever this whole thing is, 2M plus WL bar over 3W, right? And it's up to you guys if you want to choose to substitute 168 in here. I think that when it comes to all of this stuff right here, right, this is when it's going to be useful, right? But if you're not given anything, right, regarding L bar or M or W, right, this is going to be the labor supply function that we're going to be working with. And then from here, right, with any values of L bar, M, and W, we can determine how many hours a consumer is going to work, or I guess a worker is going to work. Does that make sense, guys? Maybe how we set that up, right? As you can see, right, it's very similar to the demand functions that we worked with before. And that's why I kind of emphasized how knowing the first 3 weeks of the class really like solidly is going to propel you guys in these later weeks. So we figured out what our supply function was, right? And so let's actually just plug in some numbers and see what L is going to be, right? So L is going to be 168 minus 2 times 320 plus W L bar, so that's going to be 1,680. All over 30. So this is going to be 168, right? Minus 320 plus 1680 is going to be 2,000. So this is minus 4,000 over 30, right? And I think that what I'm going to end up with is like a nasty looking decimal, or I guess an improper fraction. I think that this is, right, you could easily calculate this on your calculator, but this should be a good enough answer for the problem. Okay, so we've gotten through this question. I think that the only thing that is maybe difficult to recognize is substituting in L bar minus L, but I think that once you're able to do that, the rest of the problem kind of flows pretty easily. All right, so I'm going to erase this problem and we'll kind of move on to some different material. Let's see if there's anything else on this problem set. I don't think so. I think we can move on to problem set 5. Okay, so this is going to be extra problem set 5, and it's going to be question 6, right? And so we're told that price of a fridge is going to change with inflation. And we're told that a fridge last year was 1,000, but it's 1,100 today. And we're also told that a bank deposit grew from $100 to 104 over the past year. And so my question is, can a dollar today buy more or less than a dollar yesterday? All right. So it's a pretty simple yes or no, or I guess it's a simple yes or no question, right? But there's obviously more that has to be kind of observed when providing your answer, right? So first off, what do people think? Do people agree with that, disagree, or do you guys maybe want to take some more time to kind of think about it?
Is it worth less?
Yeah, okay. So it's going to be worth less, right? And so if you think about it, $1,000 last year was able to buy you one refrigerator, right? But $1,000 today is only going to buy you whatever 1,000 divided by 1,100 refrigerators, right? You're going to get a fractional amount of refrigerators, which isn't going to make sense. Now, what if I said, would you rather buy a fridge last year or this year? And this is a slightly different question, right? The concept is still kind of similar, but it's kind of asking you a different thing here. So what are your thoughts on this variation of the question?
I'd probably say it was better last year because it looks like inflation is more than the interest.
Okay. Now, and I agree with you there. Now, what if I said that instead a bank deposit grew from 100 to 111? Right? Does this change your opinion about whether buying a fridge today is better than buying a fridge last year?
Yeah, I think nominal interest is now greater.
Exactly, right? So the original question is actually like, what is the real interest rate? But that's kind of a boring question, and it's really formulaic, right? I think that by doing this extra little exercise of switching up the question, I hope that you guys can kind of see what real interest rate really means, right? The real interest rate is supposed to capture how much your purchasing power changes, not how much your, I guess, money in the bank per se, right? So if we were to calculate my real interest rate, you would see that it would be 1.11 over 1.1, which we see is going to be greater than 1, right? Meaning that our real interest rate is going to increase, right, or be positive. And so what this means, right, whenever the real interest rate is greater than 1, or I guess I should say whenever 1 plus the real interest rate is greater than 1, right, that's going to tell us that our purchasing power increases. Whereas if it's going to be less than 1, that tells us that our purchasing power is going to decrease. So that was just a little quick exercise. Hopefully you guys have a better idea of maybe how the same kind of concept can be phrased in different ways.
Wait, Eric, before you erase it, could we go over could you solve that? Finding the real interest rate with the original numbers really quickly?
Yeah. So
I think it was
I think that you should be.
yeah, 4%.
And so it really would just be plugging 0.4 here. And you can kind of see already, right, just that the numerator is less than the denominator, meaning that the fraction is going to be less than 1, right? And so in this case, right, when we said that a fridge, you'd rather buy it last year than this year, right? That's because your purchasing power decreased from last year to this year, which is exhibited by the fact that our real interest rate, right, is going to be negative, right? Or that 1 plus our real interest rate is less than 1. Did that answer your question, Matthew? Or do you want to?
Yeah, thank you.
Awesome.
That's good. Thank you.
All right. So before I move on, are you guys finding these questions like challenging in any way, right? Or would you rather, because ideally, I hope that these are questions that you can do, right, pretty easily, but that they're challenging at the same time. So can I maybe get some feedback on how you guys feel about these questions so far?
Yeah, I think they're definitely doable. I just don't think I could do them that quickly.
Okay, yeah. And I mean, I think that, well, for one, I've already seen the answers. That's why I'm using these questions. But I think that just with more experience, it's just going to come. All right, awesome. That's awesome to hear that you feel like they're doable too. All right. So I think that the rest of the questions are about the same caliber. And so let's go to a borrowing and a lending question, right? So this is extra problem set 5, and it's going to be question 5. And we're told that inflation is 10%. We're told that M1 equals 0. And we're told, right? So actually, I want to make a note of what there's like a difference between what the answers PDF says and what the actual just questions themselves PDF says, right? So we're going to go through 2 different variations of this question. And I'm not going to tell you what the difference is just quite yet. You'll see what I mean in just a bit. So M2 is going to be enough to buy 1,000 units of consumption in period 2. Okay. And so we're told that R is going to be 10%. And we're told that P1, so price in period 1, is just going to be 1. And so that's all the information we're given, right? And we need to, we're also given that utility of C1 comma C2 is equal to C1 C2. Okay. So borrowing and lending definitely has some tricky aspects to it, right? So with that being said, hopefully we can get the same kind of involvement that we've been getting, right? Where does anybody want to maybe get me started with this?
Could you just solve for the MRS and then set it equal to the price ratio?
Okay, so C2 over C1. And what is the price ratio in this case, right?
1 plus R.
So 1 plus R, right?
It'd be like 1 over 1 plus R.
Okay, can you maybe go into an explanation as to why you think that is?
Yeah, so it would be like P1 over P2, and then
Mhm.
P1 on top is just 1. So that's the numerator, and then the denominator would be the price of consumption in period 2, which is I think 1 over 1 plus R.
Okay, so I like what you're doing with that, and it's definitely a good idea. But I want to remind you that the price ratio that we're going to be using has to take into account, right, interest rate and inflation, right? Which is why we're going to use 1 plus rho, which is our real interest rate, because this not only
Oh.
captures how prices are going to change, which is what I think we're trying to get at, but it also captures how our money grows along with that, right? So it captures the change in our purchasing power, if you will. And so we don't exactly know what 1 plus rho is, but we have a nifty formula for that, right? Does anybody want to remind me what that is? Right? It's something that we just, right? I believe I just showed on the board.
The nominal interest over the inflation rate, right?
Yeah, so this is going to be equal to 1 plus r over 1 plus pi. And now these are things that we have, right? That's going to allow us to solve for rho, which is going to basically help us out with our C2 over C1 MRS, right? And we know that this is 1.1 over 1.1, which is just going to be equal to 1. And so all that to say that C2 is going to be equal to C1, meaning that we're going to consume equal amounts in both periods. So now that we've kind of gotten that out of the way, does anybody want to tell me what the budget constraint is for our borrowing and lending? Maybe just read it out and then I can just write it.
It's C1
Mhm.
plus C2 over 1 plus rho equals M1 plus M2 over 1 plus rho.
Okay, so we have C2 in terms of C1, right? So we can plug in a C1 right here. And we also know that 1 plus rho is just going to be equal to 1, right? And so we get C1 plus C1 is going to be equal to M1, which is 0. Remember that, right? Which is going to be equal to M2. Now, this is where, right, it can be a little bit confusing. So I know that M2 is enough to buy 1,000 units of consumption in period 2. What does that tell us about the value of M2? And I think, Malika, you had the right idea when you were telling me the price ratio. So maybe if you or if someone else wants to maybe kind of carry that idea a little bit forward into determining M2, does anybody have any ideas? Okay.
Sorry,
So
is it like 1100?
yeah, it's just going to be 1,100, right?
Okay.
Because we know that the price in period 1 is just going to be $1, and with
Mm-hmm.
inflation being 10%, right? We know that we're going to need $1,100 in period 2 in order to buy that, right? And so this is going to be 1,100, right? So that C1 is going to be 550, which is just going to be equal to C2 as well, right? And what you guys probably saw on your, if you guys have it open, what you guys probably saw on your end was not enough, right? M2 was not, right, enough to buy 1,000 units of consumption in period 2. M2 was instead just given to you as, right, $1,000, right? And so hopefully this kind of highlights that there's a difference between $1,000, right, and the ability to purchase 1,000 units, right? Because it's all going to be dependent on the price that we have. If the price is 1, those two are going to be equivalents, right? But in any other situation, we're going to get a difference in that situation. All right. So hopefully not too bad. I think the only confusing thing was maybe interpreting what M2 meant, right? But I think that we feel pretty good about that. So I'm going to erase the board.
I have a quick question.
Yeah, what's up?
So in like the book and lecture, they always use 1 plus R as the price of 2, but since this question has inflation in it, is that why we use the like 1 plus the real interest rate?
Yeah, so in a lot of cases, I know that specifically in lecture, they use 1 plus R because they haven't introduced inflation yet.
Okay.
And so when you have inflation, that's why you need to use the rho instead of R.
Got it. Thank you.
Why wouldn't you apply the real interest rate? Okay, so that's a good question, Adrian. The reason you wouldn't use the real interest rate for M2 is because you didn't have any money in M1 to kind of keep in the bank and grow, right, with interest or whatnot, right? All we're told is that we have enough money to buy 1,000 units, right? And if we know that each unit is worth, or it costs us $1.10, then 1,000 units times the price is 1,100, right? So there's no interest rate to be applied because the period in which we're buying is the period in which we receive our money. So there's not going to be carryover between periods. Does that make sense, Adrian? Or I guess to everybody? All right, awesome. Let me try to find more good problems for you guys. All right, I haven't actually taken a look at this one. This is from problem set 6, but it's not any of those like insurance or expected utility questions. It's going to be a like purchasing power question. So we're told that, and this is also, by the way, question 4. So we're told that this person receives 550 today. And she's thinking about buying a phone that costs, or a phone that's 500. And so we're told that the interest rate is going to be 10%, and inflation is going to be 20%. And so, well, what I'm asking you is, can she afford the phone next year? All right. And what do you guys think about that? So there's 2 different ways that you can go about this, right? And so I think that out of the interest of time, actually, I'm going to walk us through how you would apply this in both cases, right? So I think that for one, you can do just simply 550 times 1.1, right? And see that this is going to be equal to whatever that is. This is going to be equal to 605. And you could also do 500 times times 1.2, and see that this is going to be equal to 600, right? So in the future, she's going to be able to afford this phone. It's just going to be very close, right, as opposed to what it was in the past. And actually, now that I'm thinking about it, I'm not sure if that second method that I was thinking about would work. Let's see. So 550 times 1.1 over 1.2. This is going to be equal to 505. So I think that this doesn't exactly, I'm not sure if this does the exact same thing. I would stick to this. But I think that this does kind of show how the real interest rate works. But yeah, I would stick to definitely this way of doing it because I'm not sure if this works for all questions. So that was just a quick one. Let me try to find maybe a bit more of a challenging question within these next few problem sets. Here, give me just a second. Okay, so here is a question from problem set 5, and it's going to be question 3, right? And so in this question, we're told that a security is going to pay $100 at the end of years 1, 2, and 3. And we're told that R is going to be equal to 0.1. And we're told that another security, and actually this is not something we're told, I'm just kind of making this up. Another security pays 100, 200, and 300 at the end of years 1, 2, and 3 respectively. But we're told that the interest rate on this one is going to be equal to 0.6. And I'm asking you which has a higher present value. And another question that I have for you is, if we need to pay 150 for either security, would we buy any of them? Okay, so this is a two-part question. And I guess the first part will kind of lead directly into the second part. And so I've added a little bit more creativity to this question, but hopefully you guys are going to be able to kind of just calculate this fairly quickly, right? So I'll give you guys maybe a minute or two, and then once you guys have the answers, just maybe start pouring them into the chat. Okay, and actually I'm going to change this number from 150 to 225. Okay, and so do you have a specific value to give me for the first security? Or maybe just like a rounded value? Okay, so this is roughly $249. And do you have the value of the second security? 213, right? So that's kind of why I changed the value, because I guess for 150 you would buy both securities. But with 225 as the cost for either of these securities, right? You know that you would only pay for a security if the net present value is going to be greater than 0, which in the first case, right, it is, but in the second case, it isn't. And so more importantly, what I want to show you guys through this question. So that's a good question. Malika, the reason that you would, for the first security, raise it by 1 is because it's paid at the end of the year. So it's kind of like a year from now. But I could easily change the question, and instead of having it at the end, I could say the beginning, in which case the first security. Okay, so you must have started to raise it by 0 instead of raising it by 1. Yeah, it might have been a miscalculation. So the way that this would be structured is equals 100 over 1.1 plus 100 over over 1.1 squared over, or plus 100 over 1.1 to the third. And this one would be 100 over 1.6 plus 100, or whoops, plus 200, 1.6 squared plus 300, 1.6 to the third. And so that should be the setup for your guys's present values. And then for net present value, you would just subtract 225 from there, right? But I want you to kind of be aware that for net present value, you might not necessarily get a situation in which you need to pay for the security up front. It might say something like, suppose you need to pay for the security in year 2, right? And so that's something that you would also need to kind of keep in mind when it comes to net present value. And so I've run out of time. I'm not sure if there's any other questions that I really wanted to get to. I think that just based off of observation, you guys feel pretty good about labor supply. And actually, I think that you guys feel pretty good about investing in present value, especially in the context of borrowing and lending. Hopefully, all of the work we did about substitution and income effects last week, and I guess earlier this week, kind of is going to stick with you. And I also want to just kind of reemphasize that when we meet each other again on Tuesday, if you guys choose to come to my hours, we're going to do a ton more problems, and I'll try to get more of the substitution and income effect kind of questions. So with that being said, you guys are good to go. As always, I have my drop-in hours at 3. And if you want to just kind of hang around and ask questions, yeah, that's a great idea, Matthew. I think that, I mean, at least when I was taking the class in person, having a study group was super useful when it came to the tests. So I think that's a good idea. I don't think that, you should feel pressured into doing it, but I think that it could definitely be helpful. So yeah, you guys are good to go. I'll be here kind of just hanging around if you guys have any questions that you guys want to ask.
Can I ask a question about midterm 2, fall 2018?
Sure, yeah. Do you have it up already?
Yeah, I do.
Do you mind if I just have you share your screen?
Yeah, sure. I can.
Wait, did you say fall 2018?
Hmm?
You said fall 2018?
Yeah.
Oh, all right. Well, hopefully I get this question right because that's when I took it. Or actually, no, I took it 20. That might be a lie. 2019? I don't know. It's been a while. Either way, so okay. I see what you're saying. This isn't something that you'll need to know. I just want to kind of let you know that for midterm 2.
Oh, okay, cool.
Yeah, the cutoff is investing and like present value stuff. This is when we were still taking it with 2 midterms and a final.
Okay, I'll ask it later then.
Yeah, so this is definitely something that I'm gonna start covering next week.
All right, cool. Thank you.
Yeah, of course.
I have a really quick question.
Yeah, what's up?
Okay, so for borrowing and lending, you know, like in old Cobb Douglas examples, you can just assume that the like demand for C1 would be C over C plus D times M over P1. And then for
Actually,
borrowing,
is that like is that kind
Sorry.
of like the income share stuff?
it's from when we first learned optimization, like for midterm 1.
Oh, okay,
Like
yeah.
it's just kind of like an assumption that they make, I think. And then like
Mhm.
for C2, it would be D over C plus D times M over P2.
Okay, yeah. I never memorized the formulas, but I
But
think that it makes sense. Go on.
okay. My only question was for borrowing and lending, could we just kind of rewrite that formula? Because I know in lecture he said that for C1, the demand could be C over C plus D. And then in terms of M is now, sorry, okay, now that I'm thinking about it, this might sound kind of complicated, so I may send you an email with it. It's a little hard to explain without showing anything.
No,
but
no, no. I think that it's a good question. For
okay,
me,
maybe can you just write out like the budget constraint really quick, and I can explain it maybe that way, like C1 plus C2 over 1 plus R. Yeah.
oh, whoops. Okay,
Okay.
go on.
So and then like the old C1 star would be C over C plus D times M over P1.
Yeah.
Okay. And then so now for borrowing and lending, I think it was like in lecture where he explained that M is now going to be M2 over 1 plus R plus M1.
Times M is what?
Sorry, M2 over 1 plus R. And
Is it
then
1
just
plus R or 1 plus rho? I guess he
they use 1 plus R, but yeah, I think I should probably start using 1 plus rho. And then sorry, just before you close the parentheses, it's plus M1 on the inside. Yeah, and then the price of consumption in period 1 is just 1. So then that would be it. So then using like the same logic, he didn't really do it for C2, but for C2, would it be okay to assume that it's D over C plus D? And then in the parentheses, it would be M2 plus 1 plus R times M1. Like you're just using the optimal amount of income in terms of the future
Yeah,
instead of the present.
I don't want to give you an answer. We could definitely work through a problem and see whether that ends up being the case.
Okay, just to like save time on the test. That's kind of what I was thinking about.
Okay, yeah, sure. We can. All right. So let's just say that C1 squared C2 is that, right? And let's say that 1 plus rho is equal to what is, I don't know, 1. And so we get that 2C2 over C1 is equal to 1, which means that C2 is equal to C1 divided by 2, right? Or I guess it probably will be easier in the fraction if we do C1 equals 2C2. And so we have that C1 is 2C2, so 2C2 plus C2 equals M1 plus M2, right? Because 1 plus rho is just 1. And so we get that 3C2 equals M1 plus M2, right? And so C2 is going to equal to 1/3 M1 plus M2. And so actually, if you look at it, that does add up, right? D
Mhm.
is 1, C plus D is 3. And you have basically everything here. I would maybe just do a few more practice examples just to kind of double check that the work makes sense. But I think that actually, yeah, you probably could extend it to that and be
Okay.
just fine.
Thank you. I'll do a couple problems, just double check it. But yeah, thank you for working it out.
Yeah,
think
and
this
you can
also
kind of
works with,
see, what was that?
Oh, sorry. I think this also works with recreation and consumption problems. If you change non-wage income into hours by dividing it by the wage.
Oh, all right. Well, you guys are teaching me something today because this is not something I ever did. Just because I don't know. But no, I mean, if you find that this works, this could definitely save you a lot of time. And you can obviously see that C1 it makes sense, right? Because this would just be 2/3, which 2 times all of this is going to be 2/3, whatever this is. So if you find that this works, I say go for it. I mean, personally, I still prefer the derivations because you can see where you go wrong.
Mhm.
But it's all kind of just about how comfortable you are with everything. So I say go for it if you find that it works.
Um, could I just double check that my logic works for the recreation and consumption problem?
Yeah, sure. And keep in mind that I have to pop into my drop-in hour kind of soon. So,
Sure.
or I guess drop in half hour because it's 30 minutes. So let's say R equals, and then what do you propose?
I guess could we just do like based off the utility function,
Okay.
like and then like if we had like some non-wage income like 500
Uh,
and
sure. Yeah.
wage rate 10, I guess.
Okay. And you want like
And
an
then we
L?
could
You want an L bar? You probably are going to
yeah
need an L bar.
L bar could be like 12.
Okay.
Then we can it would be, I think, for recreation would equal 1/3 parentheses 12 plus 500 over 10.
Okay.
Oh yeah.
All right. So let's kind of work this out, I guess. And so we see that C over 2R equals 10. So we get C equals 20R, right? C is 20R plus 10R equals 500 plus W L bar, which is 120. And so we get 30R equals, yeah, I think this will probably, whoa. So this is 620. So this is equals 620. And so R equals 620 over 3, which is equal to 1/3 over 30. Sorry, it should be a 30, which is equal to 1/3 620 over 10, which is equal to 1/3 62, right? Which is what we have here. So I say props to you guys for actually recognizing this. Obviously, I think that you maybe want to see whether it works all the time. But yeah, no, I think that this is great. Good job, guys.
Sorry, right before you go to your office hours, what would it be for C? It would be like 2/3, and then what would be the inside?
2/3 12 plus 50.
Yeah.
Oh, so same inside, but just D over like C plus D instead of C over C plus D?
Yeah.
So
Dope,
actually,
that's
hold
awesome.
on
Thank you.
just a sec. If we have that C is equal to 20 times R, if C is equal to 20 times R, I think you maybe want to double check that it's different than just having it be like times 2. Right? Because it would be like times 20 instead.
Oh, yeah, it makes sense. I think if we do R first, we can subtract it from L bar to get the right answer.
Okay.
Yeah, that probably is a better idea. You're right.
All right, but this is really clever. Hats off to you guys. I'm not sure if I'll ever teach this because I'm not sure if I can memorize this, but no, this is great. And if you guys want to use this on your midterm, I think that this kind of proves that this will most likely work in most cases,
Mhm.
if not all cases. So I do need to
Cool.
run and hop into my drop-in hours, but
Yeah, no, go for it. Thank you so much.
thanks for kind of hanging around and
Thank
asking
you.
questions.
Thank you. See you
All
next
right.
week.
Bye, guys.